Welcome to Brain Vision.
For this problem on the topic of kinematics of particles, we are told that automobile A passes through an intersection 3 seconds after automobile B passes through the same intersection. If we know that the speed of each automobile is constant, we want to find the relative velocity of B with respect to A, the change in B's position with respect to A after a 4-second interval, the distance between the two automobiles 2 seconds after A has passed through the intersection. So we know that VA is equal to 45 miles an hour, and so we'll convert this to feet per second. So this works out to 66 feet per second, and VB has a speed of 30 miles an hour, which is 44 feet per second. Using the law of cosines, we have that the speed of B relative to A squared is equal to 66 squared plus 44 squared minus 2 times 66 into 44 times the cosine of 110 degrees, which means that the speed of B relative to A is 90.99 feet per second. Now, using the law of sines, we have the sine of angle beta over 66 is equal to the sine of 110 degrees over 90.99. So from here we can see that the angle beta, as we have in our diagram, is equal to 42.97 degrees. And so alpha is 90 degrees minus beta, which gives us alpha to be 47.03 degrees. And so the relative velocity of B with respect to A is equal to 91 feet per second at an angle of 47 degrees below the negative x-axis. And the change in position, if delta t is 4 seconds, of B relative to A is equal to the velocity of B relative to A times a time of delta t. So this is 91 feet per second times a time of 4 seconds. And so the change in position is 364 feet at the same angle of 47 degrees below the negative x-axis. And so we have the solution for parts A and B. Now lastly, for part C, the distance between the two autos 2 seconds after A has passed the intersection. We know auto A travels for 2 seconds. So VA is 66 feet per second at an angle of 20 degrees. And the position of A, RA, is equal to VA times T, which is 66 feet per second times a time of 2 seconds, which is 132 feet. And so the position of A is 132 feet at an angle of 20 degrees. And we can draw the situation as follows. And for auto B, we have VB is equal to 44 feet per second vertically down. And so its position, RB, is equal to VB times T, which is 44 feet per second times a time of 5 seconds, which is 220 feet vertically downward. And we know by the law of cosines, we have the position of B relative to A squared is equal to 132 squared plus 220 squared minus 2 times 132 times 220 times the cosine of 110 degrees. And so we get the position of B relative to A to be 293 feet, which is the distance between the two autos.